Hi, everybody. If I seem a little irritated, it's because I pushed the record button, and for whatever reason, my computer decided to make a decision for me and didn't record. So this is my second time through all these examples. In a normal school day, I'll sometimes go through the same examples 5 times. So I guess this won't kill me. Um, Today, we're looking at solving equations with variables on both sides. And this is the most common mistake that students run into when they're doing this kind of problem. And I want you to notice that these two equations are different. The equation on the right has variables on both sides of the equation, while the equation on the left has variables on one side. This x and this 5x are on the same side of the equation, and they have to be simplified. So we're going to add like terms. X plus 5x is 6x, plus 12 is equal to 36. Now, the problem on the right is a different situation. I cannot add this x with this 5x because they're on different sides of the equation. But for those of you who have been doing some algebra for a while, you realize you can do whatever you want to both sides. And wouldn't it be nice if we just had x's on one side? So what I'm going to do is I want to get rid of this x. Now, some people are going to say, well, you can't just throw away an x just because you feel like it. But you actually can, so long as you do whatever it is you do to both sides. So I'm going to get rid of this x on the right. And as long as I get rid of an x on the left, it's all good. And these are very different equations. Notice, this is all right to do. This does give you 0. And over here, this equation is different than the one you see on the left. Over here, we have 6x plus 12 equals 36. And on the right, we have 4x plus 12 equals 36. Now we're going to solve these two equations, and you can see they have very different answers. So in this case, we're going to subtract 12, on the left, we're going to subtract 12 from both sides, and we're going to get 6x is equal to 24. And on the right, if I subtract 12 from both sides, I get 4x is equal to 24. On the left side, I'm going to divide by 6, and I'm going to get, on both sides, x equals 4 in this case. And on the right, I'm going to divide by 4. Remember, division looks like this in algebra. 4 divided by 4 really is 1, and x is by itself, and it's equal to 6. We have two very different kinds of equations here. When you have variables on both sides, keep in mind, the most common error I see is students, after a while, they've done these type of equations for a while, the ones that are on the right here. And then they see an equation like this one on the left, and they think, oh, I want to get rid of this x. And then they say, oh, I'm going to get rid of this x, and it's all good. This is wrong, absolutely wrong. And think about, why can't you do this? If I take an x from here and take an x from here and here, I'm taking two x's from this side of the equation, and I'm not doing anything to the other side. Remember, the most important part of algebra is to do the same thing on both sides of your equation, okay? Well, let's look at another example that may make this clearer for you. I meant to include my balance scale. Now, in my other examples, I had the balance scale already drawn. I'm going to draw a balance scale. When I used to teach, I've actually bought 2 decorative balance scales at a garage sale. And basically, what a balance scale is saying is that this side, this left side over here, is balanced with this right side. And I'm going to go ahead and put some weights. Now, these weights are supposed to be equal and unknown. So we don't know how much weight we've got here. Now, these little weights, these little round weights, we know are 1 unit each. They might be 1 kilogram, they might be 1 gram, we don't know. On this side, we have another unknown, and we have some other weights here. Let's go with, I'm going to do the same example so I don't get confused. So we've got one, each one of these represents one unit. And the reason I say it's balanced is because it's level. If one side was lower than the other, then we would say it's unbalanced. Now, what I'm going to do is I want to have eventually one X on one side of my balance scale. And in order for that to happen, I need to have X's just on one side. And a lot of people say, well, why don't you just get rid of this X? And when I take it off, think about that. What's going to happen? If I take X off of one side, it's going to unbalance this scale. And which side is going to go down? The side on the right, if I take something off, it's going to be lighter, isn't it? And the left side is going to go down and it's going to be unbalanced. So to keep it balanced, I need to take an X off of both sides, just like I did before. And when I do that, you now have a new equation. And you can see what it looks like. We've got 3x's plus 3 is equal to 12 weights. Now, this was 4x plus 3 is balanced with x plus 12. And we took an x from both sides. And what we ended up with were 1, 2, these are supposed to be the same size. 1, 2, 3, and we've got 12 weights on this side. There we go. I took this x off and took one of these x's off, and I now have 3x's plus 3 is balanced with 12. I can now take these 3 weights off, but if I do that, it'll unbalance. Now this side is going to be lighter unless I take 3 off of the right side. And I now have 3x is balanced with 9 weights. And if you want to see the picture of this, it looks like this. I've got 3 unknown weights. And over here, I've got and the way you can think of division is that you divide it into 3 equal pieces, 1, 2, 3, and 3 equal pieces. And each X represents 3 weights, if you like to think of it that way. I'm dividing by 3 on both sides, so each X is equal to 3. This is a kind of a physical model of equations with variables on both sides. I actually had this ready before. All right, this last one, or this third one, I call direct conversion. And you need to be very careful of what the words mean. Words mean something. And less than is one of those that everybody gets wrong. And I want you to think about what less than means. And we're going to do a little experiment, okay? And I want you to do this with me. I want you to figure out what number is 2 less than 10. Seriously, do it. 2 less than 10. I absolutely guarantee even a third grader knows what this is. 2 less than 10, you took 10 and took 2 less, and you got 8. That is 10 minus 2. 2 less than 10 is 10 minus 2. Notice that we reverse those. That is very important that when you see the words less than, fewer than, smaller than, lighter than, slower than, they all mean reverse subtraction. More than is reverse addition, and you could try it yourself. Anyway, I'm going to go ahead and rewrite this expressions out. So it says 6, sorry, that's supposed to be a 6. There we go. Less than, triple a number. Well, when I say a number, I'm not being specific. So we're talking about a variable. And we've got triple a number is 3x. Is the same as, well, we know what that is the same as can all be written as equals. 10 That's just 10. More than, just like less than, it means reverse addition in this case. Greater than, bigger than, faster than, hotter than, all of those things mean reverse addition. The same number would just be x. So now I have an equation that I can write. I have 3x minus 6. Remember, you have to reverse the less than. Is the same as 10 more than x. And now I have an equation. Now, what you should be doing is stopping the video and solving it for yourself. You should be able to solve this now. If you watch the first example, you know what to do. You need to eliminate the x from both sides. And I'm going to show you one other weird error that people get, but do it yourself. That means pause it and actually do it. Watching me do this is not going to do you any good. You could watch math videos for the next 10 years, maybe 100 a day, and you still won't be able to do any math. Math requires that you try it yourself. So I'm going to subtract x from both sides. A weird error is to take 3x minus x and think it's 3. Be careful, that's not 3. If you take 3 dogs and take away a dog, you have 2 dogs left. If you take 3 boxes and take away a box, you have 2 boxes. 3x minus x is just 2x. Minus 6 equals 10. Some people are going to want to start by adding 6 to both sides, but that's going to lead to other weird errors. So you're probably better subtracting the x from both sides and then dealing with the two-step equation that you have left. And of course, most of you know what to do next. You add the 6 and divide by 2, and you get your solution. We have one last example. And this one really gives people issues. It's because it requires some modeling. 3 consecutive integers have to be modeled in algebraic notation. And what I mean by that is that 3 consecutive integers would be numbers like 10, 11, 12, 15, 16, 17. Those are 3 consecutive integers. Well, easy, right? What you need to do is, in order to model mathematically or algebraically, you need to start with an unknown, which would be the x. So my first consecutive integer is x. Now, how do you get to the next number? Well, you have to think about what you're really doing. Obviously, we're just counting. We're saying 7, 8, 9, 10, 11, 12, 13, 14, 15. But if you really look back to counting, it really means adding 1 to the last number. So if I add 1 to x, I have x plus 1. That's the next consecutive integer. Now I have to add 1 to x plus 1, which is really x plus 2. And if you've watched some other consecutive integer problems, you know that those are 3 consecutive integers. Now I'm going to read the question. It says double the sum of the first 2 integers. So here's my first 2 integers. When you see sum, difference, product, or quotient, you must put parentheses around them. I see this all over the place. In a lot of math textbooks, they don't put the parentheses until they're needed. And at that point, it's too late because the students are already in a bad habit. A lot of people think the sum of the first 2 integers would be this, x plus 1. And that looks good. It's sure enough, it's the sum, but the sum really indicates that you've already added them together. Just like if you say the total, you've added the numbers together and they're already added together. It is very important that you put the parentheses, and here's why. You see this word double? Most people are aware that means 2 times. So watch this. I'm just going to write exactly what I said here. The sum of the first 2, and then I double it. Well, guess what? You're going to get it wrong if you write that, because 2 times x plus 1 is not the same as if you take the sum. It is very important that you include the parentheses. Is my short version of is equal to 24 more than the third integer. So here's my third integer, x plus 2, and I'm going to take 24 more than that, so it's reverse addition. So I've got the x plus 2, and I like to substitute inside parentheses. Again, it's a good habit to get into, plus the 24. Notice that I'm reversing it. A lot of people say, well, it doesn't matter because addition is commutative. Well, that's true. But if you get in bad habits with more than and greater than, then you'll do the same thing when you're doing less than and get it wrong. All right, there it is. Now we simplify. We have to do what's inside parentheses first, which is find the sum of the first two integers, which is 2x plus 1. And this is x plus 2 plus 24, which is x plus 26. I can add the 2 and the 24. And I have to distribute the 2. I'm going to suggest that a good idea is to write the little arrows that go on the distribution until you get really good at this. And sometimes even when you're not, even when you've been doing this for years and years and years, you'd be surprised. A lot of people say, oh, I'm going to take this 2 times both of the terms inside the parentheses. You take the 2 times the 2x and write 4x, and then you totally forget what you were doing and write the plus 1. That would be incorrect. You have to take the 2 times the 1 as well because you're distributing. And we're almost done. Now I have to subtract x from both sides and yada, yada, yada. You know how this works. You're going to get the same answer as you got in the previous example. If you get a different answer, then go back and try it again. I hope this helps. Hopefully it actually recorded this time, and I will see you back again.